Hello, everybody. I will start my today's another live coding session. So today I solve this question. Convert binary search tree to sorted double linked list. Convert a binary search tree to a sorted circular double linked list in place. You can think of the left and right pointer as synonymous to the predecessor and successor pointers in a double linked list. Left and right pointers synonymous to the predecessor. I see. For a circular double linked list, the predecessor of the first element is the last element, and the successor of the last element is the first element. Yeah. We want to do the transformation in place. After the transformation, the left pointer of the tree node should point to the predecessor, and the right pointer should point to its successor. You should return the pointer to the smallest element of the linked list. You should return the pointer. Okay. Good. So let me clarify my understanding first. So in this question, I will be given the node, which is the root actually. And I will return the node again. So this, because this is a binary search tree, the root, isn't always the smallest value. So maybe this node is different. I mean, returned node is maybe it's different from root node. Okay. And as a constraint, I'm wondering if root can be none. And yes, root can be none. Okay. Aside from that, I don't have anything I do care at this moment. So let me take a look at examples. So let's say I have the binary search tree look like this. Like 1, 2, 3, and 4. And 5. In this case, what I'd like to return is 1, and this right pointer should be pointing to its successor, which is 2. Then, whose left pointer should be pointing to 1, which is the predecessor. Yep. And for this and this and this. And 1's predecessor should be pointing to 5, and 5's successor should be pointing to 1, which means that 1's right pointer should be pointing to 5, and 1's left pointer should be pointing to 5, which is the largest number, and 5's right pointer should be pointing to the 1, which is the smallest, number. Okay. So I think that the brute force approach is I do the in order traversal, because if I do the in order traversal on the binary search tree, I can visit the nodes in a sorted order. Then and create the sorted list of nodes. Yep. Once this is done, I do have to connect nodes. Yep. So this is the second step. So in this way, I can do this actually in O of n time complexity, assuming that there are n nodes in the given binary search tree. Because for the traversal, it takes O of n time because I have to visit each node. Each node once. And the second step, connecting nodes, because I have the, n nodes. And what I would do is updating the left pointer and right pointer for each node. So it should be 2 times n, which is n over n time. So in total, it will take over n time. And for space complexity, it will take O of n again, because all I need is this sorted list, which stores exactly n nodes. Okay. And let me think if I can optimize this. So O of n time complexity, I'm pretty sure this can't be optimized anymore, because I have to visit each node and update the pointer. But for space complexity, maybe I can optimize this. So I will try to think of it. So when I have this, if I do the in order traversal, yeah. So I think maybe I can do it. So if I do the recursion for in order traversal, it takes over in space. Or I should say all of the max steps space, which can be at worst O of n. So it doesn't work. But if I do iteratively, the traversal, no, it takes again over in time space for the stack. Actually, I can't come up with any optimization for this. Yeah. Okay, so I will go with this approach, brute force approach, actually. Okay. The first thing I do is create the list of nodes. So in this way, I get the nodes. And now what I will return is this one, because this is the smallest. And that being said, oh, by the way, if root is none, I will return none. The edge case. Okay. So now what I should do is I update the pointers of each node like this. So let's say I have nodes like this. In that case, I do I from 0 to this one, and I update the node I and node I plus 1's connection like this. I do this first and then shift and do the connection between this and keep doing that. Okay. So now these two are connected. The remaining thing is the, first node and end node. So 0 dot left should be nodes -1. -1 is the last node, tail node. Tail node dot right should be the first node. Okay. Then I return the first node in the rest. Good. Now I do this, build sorted rest. Okay, here I do see the traversal iteratively. Yep. Sorry. Oh, on my second node, I will do this in iterative way. So this mutates self.nose. Okay. So the traversal, if root is none, that's the edge case. So I just return. Otherwise, I do check root.left first and root, and then root.right in this order. Then for this root, I append this to self.nose. Then I do recursion for root.right. Okay. In this way, I could visit left child, current node, and then right child. Okay, this is it. Good. Now let me try run my code. Let's start with the edge case. If head is pointing to none. No, sorry. The tree is empty. In this case, I expect nodes to be returned. Yep, and this is true in line 51. So I pass this first test case. Okay, next, let's think of the case when there is only one node. In this case, the self.node is empty and self.find nodes should be called with node 1. And here root is not known, so I go to line 71, and self.find and root.left is now known. So actually, it doesn't have nothing happens in the child recursion code. I go to line 72, and this root node is added to self.nodes. Yep. And next, here in line 73, root.right is none, so self.find none, in which nothing happens in line 69. Okay, so that's it. So now I'm done with line 55, so I go to line 59. And actually, self.node length is now 1. So 1 minus 1 is 0. So this doesn't have any loop actually. I go to line 63 and self.node 0.left is equal to self.node -1. So this is pointing to the self. So node 1.left is pointing to node 1. And then line 64, node 1.right is pointing to node 1. So this is self-circular, double linked trace. Good. So, and in line 66, I return the node 0, which is exactly node 1, which is the only node in the tree. Okay, so this returns node 1, which is circular. So I pass this case. Okay. So let me speed up. So let's say I have something like this. So I've almost covered all the lines except for line 63 and 64. So just focus on this. In this case, 1, 2, 3, self.nose is, sorry, self.nose corrects the node in this way. I don't check it anymore. about the recursive function. And in line 62, I should be, because there are 3 nodes, length of self.node is 3. So 3 minus 1 is 2. So I should be 0, 1, 2. So what happens is, node 0 dot right should be node index 1. And node index 1 dot left should be node index 0. So 1, 2 are now connected. And now 2, 3 is connected in the same way. Node 2 dot right should be node 3, and node 3 dot left should be node 2. So now 1, 2, and 2, 3, these connections are done. And in line 66 and 67, I do connect the, head node and tail node. I'm pretty confident on this because I've already covered this line. So I'll go to line 69 and I return the first node in the list, which is node 1. Okay, so this is completely as expected. So like this. So I can say I passed this test case. Okay, good. So I'm pretty confident in my code and I covered all the lines. So run execute. Okay, not find, but find nodes. And I execute it. Good, accepted, and submit, and accepted. Great. Okay, so let me quickly wrap up. So today I saw the question, convert binary search tree to sorted doubly linked list. In this question, I'm giving a binary search tree, and my task is to reconnect each node in the binary search tree to the sorted doubly linked list. And in this doubly linked list, nodes are sorted by the values. And the first node, or I should say, the head node dot left should be pointing to the tail node, and tail node dot right should be pointing to the head node. Okay. So in my approach, I firstly did the inner traversal, and I guess the rest of the nodes, because this given tree is the binary search tree. If I do the inner traversal, nodes are now sorted. Okay, and then I connect each adjacent nodes, with for loop. And also I had to take care of the head dot left is tail and tail dot right is head. And in the end, I return the first node in the given, built list. The sorted list of nodes. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.